Every single day, millions of people board aircraft and travel thousands of kilometers across the globe in just a few hours. That's only possible because of one of the most brilliant machines ever invented by human beings, the jet engine. Today, we're going to look inside these incredible machines and find out exactly how they work. Before we dive into the details, here's something important to know. There are four main types of gas turbine jet engines: the turbojet, the turbofan, the turboprop, and the turboshaft. Each one works on similar principles, but they're designed for very different jobs. We'll meet all four of them today. But let's start with the one you've probably sat inside, the turbofan. Here's the most important idea behind all jet engines, and it's surprisingly simple. A jet engine does not pull the aircraft forward. It throws air backward very, very fast. And when it throws air backward, the aircraft is pushed forward. This is Newton's third law of motion. For every action, there's an equal and opposite reaction. Keep that idea in mind. Everything else builds on it. Now, let's look inside a turbofan engine, the type that powers most passenger aircraft flying today. The first thing you see at the front is a massive fan. This fan is enormous and incredibly powerful. The moment it starts spinning, it pulls in huge amounts of air, far more air than the engine itself will ever burn. And here's the surprising part. Most of that air never actually enters the engine at all. The fan splits the incoming air into two separate streams. One stream, shown here in blue, goes around the outside of the engine. This is called bypass air. The second stream in orange goes straight into the core of the engine. Here's what surprises most people. It's actually the bypass air doing the majority of the work. It gets pushed backward at high speed, and that's where most of the forward thrust comes from. Think of it like a giant invisible hand grabbing hold of the air and flinging it behind the aircraft. The core air now enters a section called the compressor. The compressor is made up of row after row of spinning blades, with fixed blades in between. As the air moves through each stage, it gets squeezed tighter and tighter. The pressure rises, the temperature rises, and the air becomes incredibly dense and energetic. By the time it reaches the end of the compressor, it's been squeezed to many times its original pressure. This is exactly what the engine needs before it adds fuel. The compressed air now reaches the combustion chamber. This is where the action happens. Jet fuel is sprayed in as a fine mist and mixed with the hot compressed air. A spark ignites it during startup. After that, the flame keeps burning continuously on its own. No more sparks needed. The gases produced reach temperatures above 1500 degrees Celsius. That's hotter than flowing lava. Now you might be wondering, how does the engine not simply melt? Great question. The answer is two things. Tiny cooling holes drilled into the turbine blades allow cool air to flow through them like a shield. And the metals used are advanced high-temperature alloys engineered specifically for extreme conditions. After combustion, the hot gases rush toward the back of the engine with tremendous force. On the way out, they hit the turbine blades. Think of it like a windmill being spun by the wind. The turbine spins, and it's connected by a long shaft to the compressor and the fan at the very front. So the engine is actually using a portion of its own power to keep itself running. The turbine takes just enough energy to do that job and lets the rest of the energy exit out the back. The gases that pass through the turbine still carry a lot of energy. They exit through the exhaust nozzle at the back of the engine, shooting backward at high speed. At the same time, remember that bypass air from the fan? It also exits backward. Together, these two streams of air create the thrust that pushes the aircraft forward. Hot exhaust from the core. A large volume of cooler bypass air from the fan. That combination is what gets a 500-ton aircraft off the ground. Older jet engines, called turbojets, burned more air and produced a very small but incredibly loud exhaust blast. Modern turbofan engines work differently. They move a much larger volume of air at lower speeds using that big fan. Moving more air at lower velocity is far more efficient, and it produces significantly less noise. That's why today's passenger aircraft are quieter, cleaner, and cheaper to operate than the jets of the 1960s and 70s. Modern jet engines don't rely purely on the pilot to manage every detail. They're controlled by a computer system called FADEC, Full Authority Digital Engine Control. FADEC automatically manages fuel flow, temperature, engine speed, thrust, and safety limits in real time. Pilots simply request the power level they need, and the computer handles everything else, keeping the engine running safely and efficiently at all times. Now let's meet the other engine types, starting with the turbojet, the original jet engine. A turbojet is essentially a turbofan without the large front fan. All of the air goes straight through the engine and blasts out the back at very high speed. This makes turbojets extremely fast and powerful, but they're noisy and burn a lot of fuel. That's why turbojets are mainly used in high-speed military aircraft, where raw performance matters more than fuel economy. Next up, the turboprop. This one is a fascinating mix of jet engine and propeller. In a turboprop, the engine's power is used mainly to spin a large propeller at the front rather than pushing air out the back. Turboprops fly slower than turbofans, but they are exceptionally fuel efficient at lower altitudes and speeds. That makes them ideal for short regional flights, small airports, and routes where fuel costs matter most. Finally, the turboshaft. This engine is very similar to a turboprop, but instead of spinning a propeller, it spins a shaft, which can power helicopter rotors, tanks, ships, or other heavy machinery. The turboshaft produces no significant jet exhaust thrust. All its energy goes into turning that shaft. You'll find turboshaft engines in military helicopters, power generation turbines, and even high-performance naval vessels. So let's bring it all together. The turbojet, fast, simple, and powerful, built for speed. The turbofan, the workhorse of modern aviation, efficient, quiet, and perfect for carrying hundreds of passengers across continents. The turboprop, slow but fuel-smart, ideal for shorter regional routes. And the turboshaft, the powerhouse behind helicopters and heavy machinery. 4 engines, all sharing the same core principle: compress, burn, expand, and push. And that simple idea is what connects every flight that has ever taken off. There are even more advanced engines designed for extreme supersonic and hypersonic speeds, such as the ramjet and the scramjet. These engines work in completely different ways and involve some truly fascinating engineering. Because they're more complex and deserve a proper explanation, we'll explore them in detail in another video. The jet engine is one of the greatest engineering achievements in human history. Next time you look up and see a plane streaking across the sky, you'll know exactly what's making it possible. Thanks for watching, and keep exploring. Make sure to subscribe, and I'll see you in the next episode.